Okay, so what I want to show in this is now let's move into arrays and how they work in C. So there's two types of arrays you can make and really two types of variables you can have. You can have stack variables that are fixed size throughout program duration. Then you can have a heap variable, which is a non-fixed size throughout the program duration. That doesn't mean the size of an array changes. Like if you had an array that was 10 elements, you don't make it 11. You actually can manage the memory in a different way. So we'll start with this this array size and we'll give it 5, and then this is the syntax for an array in C++, or sorry, C. So there we go, we've created the array. So okay, it runs, great. So one thing I want to show here is what this actually means. So what we're gonna do first is let's look at a print function of my array. And then this will probably print out a pointer, so let's do this, and then we'll copy and paste this. We're gonna look at the variable myArray, the memory address of myArray, and we're going to look at the first element, the memory address of the first element of my array. Let's copy and paste that up. So let's run this and see what comes back. So if you look at this, these are all the same value. So what does that actually mean? It means that my array is actually a pointer to the first element of the array. So the array is basically 6 long, with the first element pointing to the memory address of the next element, of the first element. So now if I look at memory address of the second element, which is in index 0, you can see how we've incremented by 4, and then because it's 4 bytes long, meaning 8 bits, so 32 bits long in total, which is right because we're using integers here, which are 32 bits. You can see 0, 4, 8, great. 2 do we appreciate. So hexadecimal, the 0x is base 8, hexadecimal, hexagon. So incrementing by 1 actually means you've gone up by 8 bits. So you see boop, 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 great. So incrementing by 4 is 4 times 8, or 32. So you've incremented by 32 bits, or I guess 1 memory slot, or however they've organized this architecture. So now that we've gotten this idea, I'm going to suppress this output. So let's do this, and then let's compile again to make sure I didn't screw anything up. Okay, so the first thing we're going to do is we're going to initialize our array, and you do that like this. So you just say int x equals 0. While x is less than the array size, increment x. So this is shorthand for x equals x plus 1. So we're going to say my array at x equals 0, just initializing to 0. And then we're going to print the whole thing out. Printf. This is such a pain in the butt to type out. You gotta do I equals, the integer prints here, new line, close it. Then we need x, and then my array at x. Oh my goodness, so much work. Okay, so we've now initialized to 0, but I want to show something that happens if you don't initialize. C++, and C operate on this garbage value concept. So if you don't put something in there, it's going to put something in there. It's also one way you can tell if you're working with a pointer. It gets initialized to garbage if you don't assign it. If you don't assign the memory address that the pointer is pointing to with a value, it will put one in there for you. So if you don't manage your pointers correctly, the program will just have garbage results. Literally, they call it, I think it's actually called a garbage value. It's not me being pedantic. Okay, so let's do this. We're going to use this change var val function. int array, and then this is how you would pass an array. If you had a double array, you would have float or double here. We're working with integers for this example, so then we have the size, which is also an integer type. Okay, so we're gonna go back and uncomment this, and then let's copy and paste this up here because I don't feel like typing. I think you get the idea. So you have boop, 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 nope, I want that, equals x plus 15. We'll just assign it like that. And then let's do this. So if you remember before, we were able to pass the single variable, like the int x equals 10. We were able to pass that x as a copy, but not with an array. Because as we looked at earlier, if I scroll up, the array value variable itself, my array, and the memory address of my array are the, oh, this is a bad printout actually. This should say 1 and then 2. What am I doing? That was super stupid. Anyhow, this should be 1 and this should be a 2, but you see how this variable and its memory address hold the memory address of the first element, the 0th element. And then this is the memory address of element 2 and then 3, so index 0, index 1, index 2. When you pass this array, with that kind of logic and what we already know about pointers, oh my god, I didn't change the name. It's probably going to give an error for that too. When you look at this logic, it edits the value because what you're doing is passing in, you're passing in the memory address for it to go in and edit directly. So like if I break this statement down and I say array at 0, what this is actually doing is going to the memory address of array 0th element and getting the value. It's actually very similar to saying this. It's the same effect. So when you're working with an array, you really have a series of pointers and you are dereferencing them in this way to grab what's sitting at their memory address. So now if I go down here and I start to look at dynamic memory, you have, this is the syntax for allocating it. You should always allocate your memory, an integer times array size. I'm using the variable from earlier. So now if I go through and apply the same kind of logic to this, let's see what this prints out. And this should be, I have no idea what kind of variable this is, so we're just going to figure it out. No. Yay, let me try integer, see if there's anything in there. 0, initialized to zeros, good. Remember, this is what that statement does, great. So what you can do with a pointer array, I mean, you can do this kind of stuff too, like you could say my array pointer at 4 equals 23, and it would make that assignment for you. You can do something called freeing this. So now if you needed to use a length 5 array like this, but you didn't want to keep it around after the program doesn't need it anymore, this is really more applicable with very large data structures. Like let's say you had an audio stream or a RF data stream with 1 million samples, and after you offloaded them and saved them, you don't really need to keep that memory around if you don't want it, or you take that input and move it to a different buffer, meaning that like where it's stored in the memory from the sampling device, you go in there and you grab it and then you take it and put it into the larger buffer that you have for data storage. You don't need that variable to sit. So after its task is finished, you can free it depending upon what the program asks for. So what I want to do is show the effect of this free and what it does. Free bird, yeah. So let's do the make. So you can see the first time through we've got a good initialization from this memory allocation, but the second time through we've kind of just filled it with nonsense. And that's the effect of free. You can see, like, if I actually printed out like the memory address, like let's look at the memory addresses. Let's look at the memory addresses and the, I guess I could have just, God, I was stupid because I could have done that a different way. I think I need to change this to a P. It's going to be a memory address that comes out. Okay. So you can see that's confusing to read, but I'll highlight. The first time through, you get the memory address and then the value all initialized to 0. But after we free it, you see how these memory addresses didn't change, right? The first one is still 055, right? This is the same memory address, but the value that comes out of this is garbage. And that's because you no longer have that memory on the heap. So this is something cool you can do in C and C++ where you can manage, you have a little bit of control over your memory. So they call it a memory leak. Like if I didn't have this statement and my program finishes, this is what they call a memory leak because I'm still controlling this memory and I never deallocated it. So technically shouldn't do that. You should always free your dynamically allocated memory. Again, this doesn't change the size. Like I don't go 5 to 6. Like I can't do that. That doesn't happen. But what it does is it lets me know. It lets me release memory after use. Yes, that's what it's for. It lets you release memory after use. Memory, that's right, isn't it? Yeah, I think that's how you spell that. Okay, cool. That's what I wanted to show with this. What an array is in C and how it works, and how now we've seen an example with a function and how that works. So this is good. On to the next one.